Seismic waves. How do we know what the interior of the Earth looks like? We can't dig down very far, about 10 miles maximum is the deepest known mine, which is basically just within Earth's crust. And yet you see diagrams like this one that show the internal layers of the Earth, and we know which parts are solid and which parts are liquid. How do we know that? Well, we know that from seismic waves. And seismic waves are essentially vibrations that travel through the Earth. And the most common way these are set up is by earthquakes. But you can also artificially trigger a seismic wave by setting off a nuclear bomb. And that's actually one way that we monitor to see if any nuclear testing is taking place, is by monitoring seismic waves. Well, it turns out that seismic waves come in three main types. The first type are called P waves, where P stands for primary, and that's because these arrive first. They travel the fastest. So if you have a monitoring station someplace away from your earthquake, the P waves are the ones that are going to show up first. Now these travel through both solid and liquid. But in the case of liquid, it needs to be at certain angles, because at other angles it will get deflected, and that's what this illustration is showing. So here we have our P wave traveling out through solid Earth. Then it gets kind of deflected off of that liquid layer. Here, where it hits the liquid, it gets deviated a little bit. Then it goes through a solid. Then it hits another liquid, so it gets deviated again, and then deviated again through the solid. So we get these shadow zones where P waves don't show up. And that's one of our first clues as far as the size of the liquid parts of Earth's interior versus the solid parts of Earth's interior. The second type are called S waves, and S is for second. So these are a little bit slower, and these only travel through solid material. So here we see our S waves going through solid part of the crust and mantle, but as soon as you hit any angle that's going to take you towards the molten part of Earth's interior, it's not going to travel through. So again, you get a shadow zone, but a much, much larger shadow zone because of the fact that it won't travel at all through the liquid material. So this gives us more information about the size of our liquid layers. And then L is for last. These are also called surface waves. And so these are the ones primarily associated with the destruction of an earthquake. Things that actually cause buildings to fall. And these are the slowest because they are just going along the surface, and so it takes a long time for that information to travel around the Earth. But all of these are how we measure Earth's interior, how we know how big the layers are, as well as knowing whether you've got a layer that is liquid or a layer that is solid. So we have seismic waves to thank for that.